reaction to action. Atlassian's proactive scaling journey. Hi, I'm Julian. I'm a software engineer on the Confluence Big Data Platform team. Today we're going to talk about how we use Druid at Confluence, the concurrency problem that we experienced, the load testing solution we created to solve that, and the outcomes of all the work that we did. So first, how do we use Druid in Confluence? The purpose of Confluence Analytics, or the Confluence Big Data Platform, is to unlock the engagement and discoverability of content within Confluence so that you're doing work more effectively. Some of these experiences that we power with Druid include the popular feed, where you can see what's happening around your company in the sense of who's reacting to what's the most popular content when it comes to comments or views, so you always know what's happening around you. Then we have the following feed, which allows you to see the people that you care about most. What are they up to? What are they editing recently? What are they commenting on? So that you're always up to date with them too. And finally, we also have the page analytics. Here you can see who's viewing your content, who's recently viewed content that you're looking at, and how many viewers you have overall to see if your content that you're creating is engaging or impactful at all, so you know what to do next time. Then finally, we have instance and space analytics. Here, you can see what's happening within not only the space that you're within, but also the whole company overall. Who's looking at what are the most active readers? Who are the most active contributors? So you know who to talk to about content that you're interested in, and to know if the content being created is impactful and engaging for people. Now, while we power all of these things with Druid, and it's been able to enable us to do many beautiful things like this, we ended up running into an issue, and that's concurrency. When a lot of people tended to log on to Confluence, which happened when, the workday started, we started to see that concurrency of having too many users at the same time bogged down the system big time. Here's what ended up happening to us. Our costs ended up increasing because we had to keep scaling in the hopes of bandaging up the problems, and the reliability of our service cratered. Many of the requests were rejected at query time, and experiences often broke. Here's a simulation of what we experience on a regular Monday. Europe users log on around the same time, or let's say like the start of the workday, which is about 12 to 1 a.m. Pacific Standard Time. Our analytics service begins receiving a high amount of recurrent requests. Druid then starts getting bogged down due to thread pool and merge buffer depletion at the broker. Then Druid begins rejecting new connections, and users begin seeing errors. And from there, errors are then seen in the popular feed and following feeds of Confluence, which is the home experience of Confluence that most people tend to go to when they open up Confluence overall. Then finally, the concurrency decreases after a couple hours and the service recovers, sometimes only after we actually scale up the service and, like I said, incur more costs. The problem here is we kept trying to guess it. We kept trying to guess what configuration needed for Druid, what scale we needed for Druid to handle the amount of concurrency that we're receiving at any point in time. That's why we created a load testing solution, to ensure we could always know what to expect and ensure that we're scaled and configured correctly for what we expect in the future when it comes to the amount of users we might have coming to our service. For this solution, we needed it to be highly concurrent. We needed a way to send a large number of requests per second at any speed that we possibly could want, considering we have infinite growth into perpetuity. For this, we use Locus. We use this because it is distributed and scalable. It supports running load tests over multiple machines and EC2 instances, and has the worker threads and take care of a lot of the heavy lifting you would have to do if you created it yourself. In addition to this, we already had it available as a platform within Atlassian called PerfHammer, which allowed it to be very plug and play. The second thing we needed is for it to be replayable. We wanted to be able to record queries from, like, let's say the last week, for example, and be able to run a load test on those queries today. And then next week, if we want to do another load test, run it against those same queries so that we can compare results based on different changes that we make at the cluster level, and verifying that things are working the way that we expect and there's no other uncontrolled variables like possibly the query patterns changing or anything like that. So for that, we ended up using Amazon Kinesis. It is highly replayable, retains events with the data stream for up to 365 days. In our use case specifically, we chose about 14 days, so you can run the same exact load test with the same exact queries for up to 2 weeks. It is also fast and scalable. It has about a 1 megabyte per second and 1,000 records per second for writes, and about 2 megabytes a second for reads, which is plenty fast for what we're trying to solve here. Now, the last part is we needed it to be accurate. If we're running the load test against a database that doesn't have the same amount of data or the same schemas or has things that are not the same within the production cluster, we would have issues trying to really understand what would happen if production got this certain load at the scale that it is at currently or could be in the future. So that's why we chose to create a mirror cluster that has the same exact data, real-time ingestion, compactions, granularities as the real production cluster. So we had a perfect picture of how things would behave there. Now here's how we ended up doing this. So the recording of queries, let's say a user requests something from our service, the analytics service, right? We will query the Druid database, the actual production cluster. It'll then return the results. In parallel to querying that database, we'll also check a feature flag to see if someone has turned on the flag to start recording queries to the stream if it's necessary for them to run a load test. That's what you see here. If that feature flag is true, we will write the Druid query to the stream and retain that for using on a load test later. At the same time, we'll respond with the results to the user, always from the real production cluster. Now, grabbing the queries from Locust. On test initialization, it'll call the stream to get the queries it needs. Kinesis will then return in batches of up to 10,000 queries at a time, and it will then fill those queries into a query queue that's shared amongst all the workers. The problem here with Kinesis is, unfortunately, we can't have so many consumers. And with Locust, beautifully, it's distributed by nature. But unfortunately, because it would create so many consumers at the same time, Kinesis would have read contention. So that's why we chose to have a queue in between that can be shared across all of the workers, all of the threads, regardless of the size of the test or the load that we're trying to send. So the query queue on initialization will have all the queries that we need. Now, replaying those queries. The Locust worker node will actually grab the query from the queue. The query is then returned to the worker thread. The worker thread then sends the query to the mirror cluster at the desired rate that we want. Druid will return those query results, and then the Locust worker will delete that request from the query queue to ensure that we're not always replaying the same requests and we're always, recreating the picture of what happened in production when we recorded those queries at the time. Now, the outcomes. We were able to run many load tests, and we're able to verify configurations and scale that we didn't have in the past that was imperative to getting the concurrency that we were looking for in Druid. And fortunately, from this, we're able to experience a 40% cut in annualized cost savings for running our Druid clusters. In addition to this, the reliability of our service was uplifted. Before, we would drop below our 99.95 SLO about 10 days per quarter. And now the reliability of our service has dropped below that 99.95% SLO 0 times since the creation of the load testing cluster. And this has been amazing for creating and uplifting those beautiful experiences to users. Thank you so much. And that was from reaction to action, the Atlassian proactive scaling journey.